All right, I'm going to go ahead and get started again. This is a slightly modified presentation that I have done multiple times for people who want an OpenCHAMI briefing. Tell me what it is. Often tell me why we're still paying for it. Um, so OpenCHAMI, Open Composable Heterogeneous Adaptable Management Infrastructure, a name decided on by committee, and it describes what it does, but it doesn't roll off the tongue. And our transcription was deciding that it's from Xiaomi. I don't know. Anyway, but it describes what it does. And when we were deciding on the name, we wanted to make sure that we were focusing our attention on the things that matter to us as we build out a system that is going to be good for all of the partners. This is consortium driven. So Dell recently joined. Dell has an opinion. Dell is sharing that with the community. The rest of the community says, thanks, Dell, we like that. Or, hey, Dell, maybe not, right? And that's how the way this is supposed to work. And we've had some really good discussions about scope of OpenCHAMI. We've had some really good discussions about stateful versus stateless. We've had some really good discussions about the way that OpenCHAMI should evolve. And the rest of this developer summit should be focused on those kinds of questions. And when you go through the tutorial tomorrow and you're like, you know what? I really don't like the way this works. I don't like how this piece of it works. I don't like how that piece of it works. These are the things that the consortium then guides us towards to fix, because ultimately this is a tool written by practitioners for practitioners. We want sysadmins to be good at their job because then they can make the systems run really well for the science we need to do. So sysadmin, so consortium driven, composable software. Sysadmins are our primary focus. Securely and quickly provision and manage HPC and AI systems at any scale. So we've done, we're looking forward to more scale testing. Our scale testing at this point has been roughly, 1,200 nodes? So we've done 1,200 bare metal nodes, which is not nothing. There's a lot of clusters in the world that are below that. And as we build, bigger and bigger and more expensive AI clusters, we're not getting high node counts the way we were, right? But 1,200 nodes is not 6,000 nodes. It's not 10,000 nodes. And those need to be the targets we're heading for as well. We've also done it on small hardware, like the stuff that we work with at Lanel, where we actually we're deploying this in a number of different ways. Those are like 10 node clusters, 3 node clusters, 5 node clusters. Bare metal, showing us that things work, but we still need to get to the scale testing piece. We had an AI, and I was reluctant to do that, to our sort of mission statement slide. I was reluctant to do that because I feel like anytime you want to make an open source project more relevant, you just put the word AI in it, and now all of a sudden it's more relevant. But we did it because when we started building AI machines, purpose-built AI machines at Lanel, we reached for OpenCHAMI and we got there very, very quickly. And some of it, this doesn't mean that it is a tool that understands how your large language model works, but it does enable you to configure a system for AI very, very quickly, and then just get to doing the science. All right. Our focus as we build OpenCHAMI, and this is where our scope discussions later this week are going to come in, is we wanted to draw the smallest box around a sysadmin tool for setting up a system that we could, and then be really careful about expanding that box. So we think automated hardware inventory. You should know what physical pieces are in your system, not just how many nodes are there and what are their MAC addresses, but you should really be able to say, I know which GPUs are in each node. I know what firmware they're running. I know what version of Linux is running on my power supply. Those kinds of questions should be things that your system management tool should be able to tell you about. Node provisioning. Ultimately, it doesn't matter how many GPUs you have, at some point you're putting an operating system on a CPU, and you need to get that operating system to the CPU in a way that is useful to the science you're doing. We think that that's not something that you can carve out of system management. There's a lot of things you can, but getting an operating system on a CPU is hard, or is core for what we're doing. We think flexible tenancy and delegated authority is important. So one of the issues that we came up with very early in the consortium is the root can do everything model. Oh, dude. Uh-oh. Do we need a ladder?
Don't touch those.
Don't. No, we're good. Okay. So flexible tenancy and delegated authority means we looked at the model of root can do everything, and we thought, well, if it's root doing everything, we don't know who did what when, and we don't know why, and we don't have that traceability. And that's one of the things that's been key to expanded authentication models and permissioning models in the cloud is no one does root level operations. They may have a root account, but that's still traced to a person, and every action can then be traced to a person. So building from the ground up this idea that there's no such thing as the super admin that does everything, while still providing for folks who don't want lots of complicated authentication mechanisms necessary to go in and customize your system. So the more flexible that can be, the better. And anytime we've had to make a decision about where authentication boundaries should go or where authorization boundaries should go, we've gone back to this. It needs to be flexible enough for you to integrate it with your own authentication system. It also needs to be able to work standalone. And for the times when it works standalone, it should not be complicated. You should be able to figure out what to do right away. Zero trust and confidential computing belong on this list, not because any system management tool can provide you with those two things. However, we think that all of the HPC systems that are being built today and that are coming out soon, they're going to need some version of this. And if you don't start with the right cryptographic signatures at the base, then you sort of build on this foundation of sand for getting your users to be able to trust what you're doing. Okay, I hope these don't keep doing this. Let's see. Maybe we do need a ladder.
HPC is easy. It's video conferencing.
Oh yeah. Printing is still my word. I mean, video conferencing and printing are the two things that I can't do. Okay. The key features, this is all on the website. It's all sort of comes out of what we were talking about our core concepts. And when we go through questions, we can talk about later, like, why is that on the list? Why isn't something that you think should be on the list? Why are we constraining scope? Why are we expanding scope? Have we hit the right, core components for handling what we need to handle? This is our basic architecture. So if you have not worked with OpenCHAMI before, it is microservice based, and we have a handful of microservices that all collaborate to handle your boot. These are all modular, and we're working to make sure that the API contracts that are being used are easy. And if you're doing the tutorial tomorrow, you will have ample opportunity to play with all of these. So at the core of everything is our inventory system called SMD. We've inherited that from Cray. This was some open source software that Cray released, and we have adopted, and we've been building on top of. I think we're going to have to rename it. That's one of the things we're talking about this week, because SMD we don't really know what that means. So we're probably going to call it something like OpenCHAMI Inventory Service or something like that. But I think it originally stood for State Management Database. We want that to be the only thing that stores any persistent information, because if we only have one database or one source of truth, then everything else can just reflect that in different ways. That's why it's drawn big, and that's why it's drawn at the center of this system. We also have a boot script service. Its only job is to hand out Pixie boot scripts. And there's some debate within the community that we'd love you to be a part of, but whether this needs to remain a separate microservice or whether we should be integrating it with one of the other services. I think that there are good arguments on both sides of that. And so this is one of the other things you'll get to learn about tomorrow. Cloud-init. One of our decisions at LANL, which the community has gone along with, is that we had a lot of Ansible that we'd been maintaining for a long time that was giving us slower boot times than we wanted. And so we were looking for, how do they do this in the cloud? How do they get fast boots in the cloud? And it comes down to this, usually a client runs on the Linux system that pulls down some information and then does an initial configuration of your node. It does not do long-term configuration. You can't make a change. You can't rerun Cloud-init. It just runs. So we built a custom metadata server. This is true for all the clouds. So AWS, Google, they have their own custom metadata server to provide cloud level information about the system. When we tied our cloud init into our inventory system, that allowed us to say things like, I want to target this customization to the node, but only if it's got an NVIDIA GPU and the firmware is at this level, and it is a front-end node rather than an IO node, things like that. We found this to be really powerful. This has cut our boot times down to like lower than I thought we could go, and that's been great. We'll talk more about that tomorrow as well. We also have two other services, Core DNS and Core DHCP. These are plugin based systems that handle DNS and DHCP. What we've done is just built a plugin that allows it to read a source of truth and then provide the DHCP or DNS as necessary. I think both of these are pretty naive implementations. They are the smallest possible implementations of DHCP and DNS, and they are enough for us to boot things at LANL, but they may not be enough for the community. Yet another place where we're looking for some collaboration. All of these microservices actually have to interface with nodes and stuff like BMCs and whatever, the actual hardware that runs science. And so what we talk about is that Magellan is our discoverer. It discovers the node by reading the BMC. And if you've got a modern BMC with a modern redfish, which is like, 2018, 2019 redfish, I would consider that to be modern. We can do enumeration of all the GPUs. We can do enumeration of all the NICs. We can do enumeration of everything that's in the system, and then we can track all of that to see if it's changing over time. And so that's what we want to do. Is we want to use Magellan or maybe other tools to go figure out, is the node changing over time, and how do we figure out when was the first time this NIC appeared in the system anywhere, that kind of stuff. We talk about booting the nodes because really that's as far as we're getting in our scope right now. We're saying we need to build an image. That image needs to be stored in an OCI registry. This is one of the things that we want to do a lot more work on because the OCI registry gives us a ton of tagging. It gives us a ton of channels, like all the things you would do with a container where you say like, give me the latest Alpine or give me version 3.9 of Alpine or whatever. You should be able to do that with your system image, and then you should be able to tag what's been tested and where it's been tested and all of those kinds of things. And this is one of the things I'm pretty excited that Dell is interested in this as well, because as we build out not just the how do you build an image, but how do you organize them, how do you store them, how do you share them, how do you reference them, how do you sign them, how do you attest them? Like all of that can come together in a workflow supported by OpenCHAMI right now. We have always at LANL done diskless, I guess stateless diskless nodes. That doesn't mean we think that diskful, stateful nodes are bad. It's just we don't have the right experience to write the diskful portion of this. And so we're also glad to see that not only Dell, but there are several other partners who are like, we would like to collaborate on what diskful means. And we'll be talking about that this week as well. Is diskful, we're provisioning scratch space on the disk, like ephemeral disks that can be used and then wiped? Or are we talking about installing an operating system? Are we booting from the disk or are we booting from the network? If we're booting from the network and then activating the disk, do we have ways that we want to see this, right? And that's part of the discussion that we're going to be doing this week. So that's booting a node from OpenCHAMI's perspective. Is we add it to SMD with Magellan. Once it's in SMD, all these other microservices know about it. And when you say, I would like to boot, it does all of the right networky things to get you a system. We found this to be incredibly fast. We're doing full system boots in a few minutes. I mean, post is not something we can control. So post plus a handful of seconds is really what we're targeting. The only other thing I didn't talk about up here, which should be, actually, there should be two things here. OpenCHAMI, which is this command line tool that we wrote at LANL because we were tired of writing all the curl commands that we needed to access the microservices. There's also a Rust-based library for calling these same services called Manta, and Manuel is here from CSCS. He's one of the core maintainers of that. We're working together to say, well, we've got two different client sets. You can use the one you want. You can use the Rust library to maintain if you want to, or you can use I think it's Python or Go that we've been using it at LANL. Before I move on, are there questions about this basic architecture? Is there anyone here who's like, I still have no idea what OpenCHAMI does? Can you explain this part more? Okay. Is anyone asleep? Raise your hand if you're asleep. Okay. Okay. So as we talk about these components, I was talking about like these things we build, but those things we don't build. And one of the core pieces, and this is in one of our RFDs, is that the best code we can possibly use is supported by a larger community than ours. So we wouldn't write our own kernel. The Linux kernel community is doing a much better job than we are. So we're looking for other places where we can take things that are not core to OpenCHAMI and we can use a third-party tool to accomplish that. And so these are the areas where we've said, no, third party should handle that. And if we can move anything over into that third party column in the future, we want to be doing that because it's just less for the community to have to maintain, less for us to have to support. In open source, a yes is forever, a no is temporary, and forever is a really, really long time to maintain software. So we're looking for what is the right way to do TPM enrollment. We've got a recipe that handles this with Keylime right now. We think Keylime may not be the right thing going forward. We haven't integrated it in a way that we're really taking advantage of it. There are other things. We want to know what you think. Our API gateway, we've used 3 or 4 different API gateways. They are all fairly simply configured. We're not saying that anyone has you must use a proxy or you must use Caddy or whatever it is, right? But if we're going to if we're going to look at all of these third-party options, we should have a good idea as to why we would choose one over another. OIDC authentication, OpenCHAMI has no idea who you are and should never have any idea who you are. Your site should know who you are. Your site should tell us what you're allowed to do. And then OpenCHAMI should enforce that. And so that, how do we authenticate users and how many users do you have and how many kinds of groups do you have? That is all a site decision, and we have no software that has an opinion about that. The other thing to mention here is at the core of our authentication and authorization model is a standard called JWT, JWT, JSON Web Token. It is pronounced JOT, and I don't know why. And what these are bearer tokens that says, here's who I am, here's who has signed this JSON document to attest to who I am, and here are the things that my site has said I am capable of doing. And then OpenCHAMI has to look through that. So we currently have 2 different sort of tools that we are kind of using in OpenCHAMI that handle exchanging a token from your site that says, here's who I am, with a token that we can use inside OpenCHAMI. And so that's a piece that we would like to put on the third-party side. It's currently kind of half on the first-party side. And so let's figure out how not to write our own crypto. Let's figure out how not to write our own JOT libraries. Okay. So we mentioned that this, I guess one of the core principles that we didn't talk about a whole lot is that we think that the cloud management model for HPC is something that we should adopt. And when we say cloud-like, one of the things we're talking about is cloud-like security. This idea that there is no root, that comes from the cloud. We've had a long time to figure out how to run on AWS or Google or whatever with this idea that you are not root and you get narrowly scoped permissions only to do what you need to do, and they expire. And when they expire, you have to ask for them again. We want to do the same thing. We want to also introduce cryptographically secure identity of the inventory. So if I've got a GPU that is running a particular version of the hardware, I should be able to attest that with a certificate and store that in a database and be able to go back to it and find out, like, well, when did this change? And if I probe it again and try to run the same SHA, am I going to get the same answer? We want certificate management to be something that you can handle at your site, but we want all of our certificates to be, we want operations to be prepared that every certificate will rotate, and it will rotate much sooner than you think it should, so that you never get out of the habit of rotating certificates. We've seen too many problems, and this was one of the things we talked about early on with OpenCHAMI. We've seen too many problems with, well, we set that expiration for 2 years from now because we're not going to have to think about that. And then 2 years rolls around and, oh no, we can't get back into Kubernetes. Crap. So we want to make sure that our internal certificate management happens with automatic rotation, and we've chosen ACME for that, which is a protocol. There are multiple implementations of that protocol. You probably have an ACME compatible certificate authority someplace in your infrastructure already, and that could be plugged right in. Or you can use the third-party one the way we've set it up. We've also taken this idea that you have to be able to do something locally, and you like in a small way. You also need to be able to expand and do it at like full-scale cluster size. So storing a secret is another one of those things. We've got an option for managing secrets on disk in a file. We wouldn't recommend it. But when we're doing tests to figure out if things work, having to set up and unlock a vault before we can issue our test slows our testing down. So we want to make sure that the vault secret management is an option. It is the option we would absolutely recommend for production. But if you're doing development, we want to give you a better experience for cycle time, because all bugs are shallow when you can, fight them over and over and over and over and over again. So
This screen about to.
no, just this.
Cool, thank you.
Okay, so we talked a little bit about the CloudInit metadata service. I want to talk a little bit more about CloudInit. One of the things that we don't like about CloudInit, the client itself comes from Canonical, the people who bring us Ubuntu. And it is standard, it is included on every Linux distribution I've found. I've not found a Linux distribution that does not have CloudInit included. That client expects not to need to authenticate to go and pull data about the node. And so this is things like, what rack am I in? What's my instance ID? What like IP address and stuff you can get through DHCP, but you can put those in there as well. What other groups am I a part of? And what actions should I take on boot to customize this node? So we would like to be able to put things in there that might be secret. But if there's no authentication, then we have to figure out how to protect that secret. And a Slurm munge key is a great example of this. So what we've done is we've included something called WireGuard, which is a VPN, a very, very lightweight VPN, which allows us to set up the VPN based on TPM authentication. So we know that the node exists. We know that the node has this TPM signature. We use that to start a synchronous VPN. And it's point to point. So server to each client is separate. So clients can't route to each other. And then we use that as the transport for bringing secrets in. So the next question was, well, how do I prevent somebody who's running a job on my node from just issuing a curl command and grabbing that secret? And our answer is that we only start the WireGuard tunnel during boot, and we shut it off at both the client and server level once boot is complete. Which means that once you've gotten to the point where you're multi-user, once you've gotten to the point where SSH is enabled, the WireGuard tunnel is down. So we've added a modicum of security around transporting things like the munge key over CloudInit, and this is built into our CloudInit metadata service. The model for this is not all that crazy. It's kind of what they do in the cloud world. They just do it at the switch level. And we don't have control over switches, and we don't want in OpenCHAMI to have any control over switches. So doing this at the node level gives us an option. If you happen to be running a DPU architecture, if you happen to be running, certain different kinds of switches, you can get a better security model around this, and you don't need what we're doing. But like we said, this has to work at small scale for an individual sysadmin. This also needs to expand to the kind of thing that a full cluster would do. Okay, so we are sysadmin focused, and I've said this a couple of times, and this is on our website. No user that is running a job on a cluster should care that OpenCHAMI was involved in getting that cluster stood up for them. We don't manage workload managers. We don't do all of those kinds of things. Sites have very, very different ways of handling that. What we care about is that the sysadmins are responsible for the uptime of the system. And so when they have tooling that is hard to troubleshoot, it leads to downtime. When they have tooling that when it breaks, it requires downtime to fix, like the users notice that. So the only reason the users should know about your system configuration tool is if it is getting in the way of their science. And so we want to make sure that we are targeted specifically at the sysadmins whose job it is to keep these systems up and running. And what we've been doing at LANL as we go from system to system, building out new capacity, is we've been talking to the operations team. And we've been saying, what are the things that you spend time on that you didn't expect to spend time on when you came in this morning? How long does that take? What are your largest actions? What are the things you have to do over and over again? And what prevents you from setting your upgrade cycle or your designated system time completely on a cron job? They've been giving us a lot of really good answers. And so we've been working towards an operations team at LANL using OpenCHAMI that can, and Nick Jones is going to talk about this later this week, but they can basically schedule all of their system upgrades as a cron script that runs at 5 a.m. And, yes, we need people on site for handling things, but it's usually done by 5:30. And that's it, right? So these are the kinds of things that we're trying to target for sysadmins. The quote that you can't see on these screens is from the first systems team that we asked to run a production system using OpenCHAMI. And this is not our developers. These are people who didn't write the software trying to use it. And what they say is it's hard to emphasize the impact of the speed and simplicity of the deployment process and the flexibility and agility of the system. We were able to identify issues and quickly fix them. The ladder's going to come out. Yeah. There were lots of little things that would normally add up to days of effort, but rebuilding was so easy, we got to do things in an afternoon. And that's been another piece here is that if you give sysadmins the ability to do a cycle time of minutes rather than hours, then they are more willing to adapt to the tool, figure out how to use it, rather than feeling like they can't touch anything for fear that it will lead to an extended downtime. So as we move forward with this, we want to be thinking about not just the systems we're building, but we also need to be thinking about the sysadmins who are going to be responsible for fixing things when they go wrong, and what are the things that we can do to help. This also means, as we constrain the scope of OpenCHAMI, that we believe that there are other experts out there, and they may be on the same team, you may even have the same people doing it. But we have decided that if you are an operations team member trying to keep an OpenCHAMI system up and running, get it deployed and get it running, stuff over here is for you. That stuff over there, that's for somebody else. And so we may have a small team of 6 people that actually does all of this, but we would consider this to be system management, and we would consider that to be something else. So we do not expect our sysadmins to develop HPC jobs. Maybe at some sites you do, but we don't. We want to constrain scope, and so this is how we do it. We don't think fabric management is something that OpenCHAMI should be doing, or setting up a network for your management network. I'm not saying those things don't need to happen. Of course they do, but OpenCHAMI's scope is narrow enough that we can have other tools that do that. Yeah.
So our people said the power cycle across them because that's the projection system.
Okay.
And he said right now if they were to do that, it would take a few minutes.
Okay.
But the people on the Zoom could still see everything. They're seeing the blips and things like that. They didn't like this being this power cycle. So
Okay.
I don't know if you want to wait till after you're done before Yogi comes on.
Yeah, I'm almost done. I think we're going to do a full reset of the system to try to see if that helps. I think we'll do that. I mean, actually, I think we're probably fine for the next 10 minutes to finish this out and then go. But if this is really bothering you and we should break now, just raise your hand. We can show of hands. Break now? Okay, 10 minutes? Cool. Yeah, that was what I thought. Okay, cool. So this is also another piece of our, how do we constrain scope for OpenCHAMI within the community? And this is what we've decided. None of these decisions are something that we cannot revisit. If you're out there looking at this and you're saying, boy, Alex, you got that wrong. No, we got that wrong and we can fix it. Okay, so we talked a little bit about the boot speeds. We've dined out on this story for a while. I feel like I've told it over and over again, but it was really, really cool the first time we deployed OpenCHAMI on production hardware, I guess formerly production hardware. We literally saved it from being wheeled off the floor just because there happened to be enough power left in our power budget that we could keep running these things. But over the course of a couple of months, we went from having 650 nodes available to what, I think down to 200 or something like that, as we tried to, keep these circa 2018 servers running. But what we had been doing to maintain them previously, we would take 8-ish minutes to boot the cluster. When we switched it over to OpenCHAMI, we were able to get it to post plus about 40 seconds. So post plus 8 minutes versus post plus 40 seconds. And for us, that meant a full system reboot was like 5 minutes on these systems. If you can reboot a full system in 5 minutes because you think you can fix something, that doesn't require the same level of planning that it would take if a full system reboot is going to take a whole afternoon. And we found that this was a really, really good way of proving that OpenCHAMI was ready to run on real hardware. And it was part of what led us to prove that out and then start to work on it for our first purpose-built AI system at Lanel. If you have questions about this, we can go through more. A lot of this is covered in the tutorial tomorrow. Okay, so a couple of things on engineering. I like this quote. I wish I could find the source for it, because at first it looks wrong. Any idiot can build a bridge that stands, but it takes an engineer to build a bridge that barely stands. So when you meet the requirements for a bridge, and then you keep adding a bunch more concrete, yeah, it's going to still be there, but you're going to have to pay for all that concrete. You're going to have to maintain all that concrete, and it's not going to give you more cars across the bridge. We want to kind of look at this the same way. We want to engineer things such that they meet the requirements, and that's it. So we've been talking a lot about how OpenCHAMI might enable AI workloads through better GPU stuff. We don't have any requirements that can show us what OpenCHAMI could actually do in that world. I think once we boot a CPU and add the drivers for the GPUs, I think we get out of the way. Because if we were to do more, we would risk adding concrete to a bridge that's going to stand up just fine. So I wasn't sure I had this slide in here. These are the engineering principles. We've talked about a handful of them already today. Sysadmin is responsible for preventing downtime. Prioritize reduction in unplanned maintenance activities. If you didn't know you were going to do it when you came in this morning, we shouldn't force you to do it. Eliminate complexity. Well, it's HPC. There's going to be complexity. Where you find it, it should be transparent. The user should understand where the complexity lives, how to get their hands around, or the sysadmin should get their hands around it. Yes, Larry.
It's ambiguous. It means something else in computer science than what you just said.
Okay.
Right? Transparent computer science means you can't see what's going on.
What?
You look up the definition. Computer science definition is that something is transparent, you don't see the details. In the real world, if something is transparent, we do.
Okay.
So I would suggest not using that word.
How should I reword this?
What do you want? It's visible. It's exposed.
Okay, exposed. Yes, where complexity is useful, make it exposed.
Expose it.
Yeah.
Expose it.
That works. Thank you. I am not a dyed-in-the-wool computer scientist, as it may be.
It's always subtle.
Cool. I can fix that. The best code for OpenCHAMI is written by a larger community. We covered that. The best way to fix a distributed system is not to have it. So one of the things that we're finding is when we find these distributed systems within HPC, a lot of them they don't need to be distributed. We don't need an HA system if we can bring the system back in less than a second, right? We can run a singleton, and then in less than a second we can bring it back. There are places where an HA is absolutely required, but let's be really careful that we only put a quorum algorithm in place where we actually need one, not just because the tool supports it. HTTP REST APIs, we have as a community discussed other sorts of APIs. What's the GoRPC, the gRPC stuff we've looked at a couple of other things, OData. HTTP REST APIs is where we've stayed. and we anticipate staying there for a while, but that's up for discussion. We don't care. Yeah, sites authenticate people. OpenCHAMI says, here's what you can do. OpenCHAMI is agnostic to your operating system. You can run whatever you want on your compute nodes because nothing in what we've done today, what we've talked about, says this has to be a Red Hat based system or an Ubuntu based system or a Gentoo based system. I don't care, right? We don't care how you deploy OpenCHAMI. At LANL, we have a recipe for running it using Podman Quadlets, which many of you are probably not familiar with. I wasn't when we started. I'm very happy with them now. NERSC is planning on doing Kubernetes for their deployment model. That's great. I think that this fits really well in Kubernetes. We have seen other folks who want to do Docker Compose. We've seen folks that want to do other deployment mechanisms. By not committing to one, we're not forcing you to adopt a tool that you're not comfortable with in order to then learn this. What we have heard is that things like Kubernetes updates move too quickly, even though it's great for what it does. If I want to build a system and then I want it to continue to run for the next 5 years, I don't want to have to think about going back to upgrade Kubernetes every quarter because that's just wasted work. Things like that. But if you're doing Kubernetes, this is great. We don't care what your workload manager is. One of the things that I'm hoping we get a chance to talk about this week is switching between Slurm and Kubernetes, the way we are trying to do it at LANL. We think that both of these things are necessary for our AI workloads. And so we want to figure out the right way of doing that. There's a ton of tools. We have found that rebooting nodes into different node images is best for us. It gives us the flexibility we want and need. Other people like Slinky for this. But we don't really care. And if you want to use Flux or if you want to use any of them with Fuzzball, any of the other workload managers, we don't care. And OpenCHAMI can support all of them. I think we've gone through all of this. This is an older slide deck, so we've got a handful of notable systems. Helios and Selene, these are our AI systems at LANL. They've been in production for a handful of months. Users are happy. We've got a handful of other systems that we anticipate coming up within the next year, and they're listed here. We're actually at the site update going to see if these things are still on the list. If they're not, then other systems will be. We've seen evidence, although we don't have a site report, that OpenCHAMI is being used in production at other sites as well. And so we're trying to get a head count, like who's running it, what do you like, what do you don't like. With the partners, that's easy. With the rest of the community, you got to tell us because otherwise we won't know. This is more about LANL. So at LANL, we have defaulted to OpenCHAMI. This is our default for running a system is OpenCHAMI. That doesn't mean we can't do something else if the needs are there. But our goal is to take all of our existing CSM systems and transition them in the next couple of years to OpenCHAMI, and we're starting to plan that activity today. So LANL is 100% in on this, and as we go forward, we anticipate that we'll add to this list. We've got a handful of test clusters that we're working with. I mentioned the 1200 node cluster, or the 650 node cluster we did the boot on. We also have a 1200 node cluster. We used that one to test out what's it like to run multiple copies of OpenCHAMI to get more scale, rather than trying to do one big vertically scaled thing. It was cool. I don't think that it led to any groundbreaking discoveries, but it was cool. We would like to go further, and we would like to figure out what is the right balance. And we've got some RFDs to talk about that later today. The other thing that I will mention, the tutorial that we will be giving tomorrow started its life as a class where we gave interns the opportunity to learn how to build a supercomputer. And the Supercomputer Institute, we run it every summer at LANL. If you know any interns that would like to spend the summer in New Mexico, it's pretty cool. And so we took people who were geology majors, no HPC background. And we said, here's what the hardware looks like. I mean, we've also got HPC folks, but here's what the hardware looks like. Here's what the software looks like. It's up to you to learn how each of these pieces work, and then you build a system, and then you can use it for something. So our current tutorial started its life as the way we teach interns with no background how to run a supercomputer. We're really excited about it. We've still got, I think, 4 or 5 clusters that the students have run for us this summer. that are running OpenCHAMI. It has become part of the fabric of what we do. I'm not going to go into these in detail today, at least not right now. We are getting close enough to lunch, and we're going to do our site updates in a few minutes. But we will be going through more details about our image builder, how we use it, the things we want to do with it, our metadata server, how we are evolving that, what we've used it for, the challenges we already see in it, and want some community support on. Oh, and then hopefully we'll get a chance to talk about our pipelines. So this is a picture of what we do with GitLab to build images. We can explain it. It works for us. But we would like to find some more commonality with the rest of the community and figure out where are the things that are GitLab and LANL specific for this for us, and separate them from the things that are generally applicable for the community. And then we'll talk later today on what we think is necessary to call OpenCHAMI 1.0 and whether that's something that we care about at this point, or whether we are comfortable continuing to sort of do dot releases for a long time. I mean, there's nothing wrong with that. All right, you're already on our Slack if you're here, I hope. If not, that QR code that you're seeing all over the place, now's the time to join. And we'll be going through the roadmap issues, well, if that'll come back. And I think it was in the email, the welcome email was sent to you as well. So so you can join for that way. And I think with that, I will stop. And I think we can do the reboot of the system here, and then we can do our site updates, and then we can have lunch. Does that work? Any questions?
Yes.
Okay,
Long term.
long term.
A lot of our sites have had problems with dependencies. An example, Python, OpenSSL, GLC, and they become incompatible issues, and have to go further away externally. We love to
Okay, so I'll repeat the question for folks online. Over the past 20 years, or well, for as long as there have been computers that run operating systems, there have been dependencies. And when those dependencies get in your way, you have to throw away the old stuff and come in with new stuff as you go from one generation to the next. Is that the thesis there?
Yeah, sometimes it stops you.
Yeah. And sometimes these things stop you from doing a meaningful upgrade, because while you may want to upgrade one piece, you can't get a dependency that will support it. And so the question is, how does OpenCHAMI envision this? And so there's two pieces to the answer. One of them is with the OpenCHAMI software itself, we make an effort to continually build with the latest Go. So they're all Go microservices, meaning that if you get a new version, it's going to have the new dependencies in it. And those are transparent, and those are tracked, and those are attested, and that's all going to work. We put them in containers to take them out of shared dependencies on system level stuff. And we make those containers as small as possible. We started out using the secure base images from ChainGuard, which are called Wolfie. License change has shifted us away from that. And so we're now looking at either the Red Hat, they've got a weird name for their base image, or the Alpine base image. I think those are the two that we have worked with, the Rocky version of that. Those are continually updated. And if we find a problem, like GitHub has bots that go and look for incompatibilities, and we fix them. And so it will even propose a fix for those kinds of things. So on the OpenCHAMI software itself, we're covering it through automation, we're covering it through repeatable builds, and we're covering it through having the smallest possible cross-section of dependencies. If there are other things we should be doing to try to future-proof, I would love to hear it. But these are the things that, based on our experience at the TSC, have helped us not have such a significant problem there with that. On the system side, where you're running an operating system, since OpenCHAMI doesn't really care about that, we don't really have to, I don't have to answer that question about your system image. However, Image Builder does kind of the same thing that we would do with a container. And it makes all of those things transparent. And so things like Dependabot can scan your system images in an OCI registry and flag incompatibilities and flag dependency issues. It doesn't prevent you from having them, but it does make them easier to see. They are exposed, if not transparent. Does that answer your question? Other questions? Yeah.
I like your secrets and injections about it. And that's pretty cool. I recently thought through this on another management tool, and next thing that I had picked up and looked through was the ongoing secretation after the recording secrets. And he said it doesn't sound like you can reestablish that we stand back to OpenCHAMI.
No, but so let me repeat the question. So first, he praised me. He said, your WireGuard solution is great. I really loved hearing about it. There was something after that, but I'm not. No. So he was asking about the ongoing rotation of certificates. And I don't think CloudInit, and so CloudInit will absolutely not do that. So if your munge key is changing and you want to send it back out, I don't think that CloudInit is the way to do that. But I also think that once you've established the identity of the node, you can use that to bootstrap other forms of secure communication. And so getting a token that then allows you to go to Vault, or getting a token that then allows you to check out a secret, those things are enabled by being able to then first bootstrap with CloudInit and then do something else. And so that's what I would recommend is bootstrap with CloudInit and then move on to something that is more secure, designed to be secure. Okay, cool. He said that's exactly what they did. So this is also a fantastic idea. Other questions? Anything online?